When we were looking at functions earlier, I mentioned how every function can be created from basic ones via different translations. Let's have a look at translations. Horizontal shifts. So when we replace x with x minus h, y becomes function x minus h, and basically it will shift it to the left or the right depending on whether we're talking about a positive number or a negative number. And if you're unsure where it's going to go to, basically think about where the origin is. So solve x minus h is equal to 0, because originally function x, originally it was 0, but now x minus h has to be 0. Solve that, that tells you where it's been moved to. Then you could have a vertical shift. Vertical shift, so it's the y values we're talking about. So now we replace y with y minus some constant number. Y minus k equals function x, although we don't normally see equations written like that. We do in some situations, but not many. Normally we would see something like this, y equals function x plus a constant. But really that constant is grouped with the y value, and that's why it's a vertical shift. And again, if you're unsure, although that one's a little bit more obvious when it's written in that format, whether it's gone up or down, but if you are unsure, again, solve that y minus k equals 0, it tells you where it's been moved to. So, okay, let's do an example. So we've factorised it by completing the square, and we've got this. Now we look at it and go, I know I've got the basic curve y equals x squared. So it must be that, because we see the x squared. But what have we done to it? Well, minus 3. I've shifted it 3 units. And it must have gone to the right, because x equals 3 would make that equal 0. So, there we go. Let's move it 3 units to the right. What else have we done? Oh, hang on. We've also shifted it up 4 units. Let's do that. And we have our new curve. There it is. Ooh, what about this one? X squared plus 2x plus y squared minus 4y minus 4 equals 0. Well, I see the x squared and the y squared. I know it's a circle. The coefficient of x squared and y squared is the same. If I complete the square on it, it becomes this. X plus 1 squared plus y minus 2 squared is equal to 9. So my basic curve is the circle. X squared plus y squared equals 9. What have I done to it? Well, grouped with the x, I've got this x plus 1. So I must have shifted left 1 unit. We moved it up 2 units. This time, this is one of those situations where grouping it with the y is good. So y minus 2, let's shift it up, and there's our new circle. I probably should have written in 3 for the radius there, but anyway. 2x squared plus 8x plus 5. I'll complete the square on it, but it's usually easier to complete the square of x squared rather than 2x squared. So I'm going to divide everything by 2, so I've just got x squared. Okay, complete the square on that. Then multiply back out by the 2, and we have y equals 2 outside of x plus 2 squared minus 3. Again, we're starting with our basic parabola, y equals x squared. What have we done to it? Well, actually that 2 out the front dilates the curve. We'll look at dilations in more detail later. But basically, it's going to make it steeper. So let's make it steeper. Then we've shifted it left 2 units. There we go. And finally, down 3 units, and we have our new parabola. Reflecting curves. So reflections is another way we can change our picture. So vertical reflection, and that's when we change x with negative x, because if we're reflecting it vertically, then the x values are changing. Becomes function negative x. Reflects in the y-axis. Now you don't have to reflect in the y-axis, you can reflect in any line. If I wanted to reflect in another line, let's say x equals a, I replace x with 2a minus x. Okay, let me show you why. Here's function x. Well, if I just reflected in the y-axis, there's function negative x. But I don't want to reflect in the y-axis, I want to reflect in x equals a. So if I shift the curve to a, now I have a reflection in the line x equals a. So it's 2a I shifted across. We could do a similar thing horizontally. If I replace y with negative y, so now it's the y values we're changing because it's a horizontal reflection. In other words, negative y will equal function x, although we'd probably more likely see it like that. Y equals negative function x. Reflects in the x-axis, but again, if I wanted a different horizontal line, I would just replace y with 2a minus y. Let's have a look at that one. Here's function x. Reflected in the x-axis, it's now minus function x. Shifted up to a, now it's reflected in the horizontal line y equals a. Reflection in the origin. Well, that's actually what we call rotation. A rotation is actually reflecting through the origin. So you reflect in both directions, the x and the y. So it becomes minus function minus x. A reflection in the origin, same as rotating the shape 180 degrees. So let's show you. Here's function x. If I did these two different reflections, I should end up with a rotation. So the first thing I'm going to do, I reflect it in the x-axis. So it's y equals negative function x. Now I'll get that shape and reflect it in the y-axis. It's now y equals minus function minus x. Have a look at the original picture. Have a look at the final picture, and you can see what we've done is rotated that curve 180 degrees. Let's try this one. Y equals negative x plus 1 cubed plus 2. It's our basic cubic. There's my very dodgy looking cubic. What have we done to it? I've reflected in the x-axis because it's minus the function. I've shifted it left 1 unit, and I've shifted it up 2 units. There's our new cubic, its position. Y equals minus 2 to the power of minus x. Well, actually, the way I phrased that, I should have put a pause in there, shouldn't I? Because it sounds like I just said minus 2 to the power. Try again. Y equals minus 2 to the minus x. The pause is very important on that one. There's the basic curve, 2 to the power of x. We're reflecting in the origin because both the function has been made negative and the x value as well. They've both been made negative. So I'll just rotate it. And there it is. Okay, so 4a and 4b, let's start moving pictures around.